Alrighty guys, so let's talk more about standard form. I am going to look at page 60 on the inside here, which if we're doing it in the packet, I'm pretty sure is page 12 in that packet. Okay, so last time we talked about standard form. That is another form of a line that looks like ax plus by equals c. Now, unfortunately, A, B, and C tell me nothing about my graph. Yeah, it's kind of a bummer. I can find the slope kind of quickly, but I have to remember another formula, and I hate having to remember another formula. If I'm looking at an equation in standard form, then I can quickly find the slope by doing negative A divided by B. Okay, so one thing we want to be really good at when it comes to any equation of a line, but also standard form, is how we graph it. So let's say, for instance, we had the equation 2x minus 3y equals 12. That is a graph or a line in standard form. And so if I want to graph, normally what we were doing before is we had to plot a point and then do the slope. The thing is, I can get the slope here kind of easily, but I don't have a point to start from. So truly the quickest way to graph something in standard form is by finding the X and Y-intercepts, which we're going to do a lot of in the front here. But I want to practice another way as well because some of us might feel more comfortable doing that. So another way to graph is that I have to change the form. So I'm going to change this from standard form to y equals mx plus b form because it's pretty easy to graph when I'm in y equals mx plus b. But to do that, I need to get y all by itself. So to do that, we want to move the x to the other side by doing the opposite. So we'll subtract it. We'll have negative 3y equals, now these aren't like terms, so I have to just write it out, negative 2x plus 12 because it's positive. And then to get y totally alone now, I need to divide by negative 3. And over here, I need to fully divide everybody by negative 3. And so y will be alone. And negative 2 divided by negative 3 is positive 2/3 x for the slope. And then 12 divided by negative 3 is going to be a negative 4 for the y-intercept. So then once I have it in y equals mx plus b, it's pretty easy to go graph. We can plot that y-intercept on the y-axis at negative 4. And then from there, do the slope, which is up 2, forward 3. And you can do it a bunch of times, but this grid kind of sucks, so I won't. There you go. Now again, there is another way to graph. We're going to talk about that in a different video. We want to be really good at changing to slope-intercept form. We did that here. I'm going to do another example now, though, just in case. So let's say, for instance, they give us a standard form equation that looks like x plus 3y equals 15. You're always going to be doing like two things to get it in y equals mx plus b. The first thing you're always going to want to do is add or subtract x away. Always the opposite. So in this case, the x here is positive. I'm going to subtract it away, both sides. Once I do that, we'll have 3y equals, now these are not like terms, so I just write them out in order, and we want to put x first just to be alphabetical, and then plus 15 since it's positive. And then the second thing we'll always do to get in slope-intercept form, which is y equals mx plus b, is I need to get y totally alone, which it could be at this point, but in this case it's not because there's a 3 attached to it. So you will divide or multiply the number in front of X, or in front of Y rather, away. Now, normally you're probably going to divide, like here I'm going to divide, but you might have to multiply if it was like a fraction, which it shouldn't be, but weirder things have happened. So we'll divide by 3, and we have to divide everybody by 3. So we'll have y alone. Now, really in front of this x right now, there is a hidden 1. So when I write out the slope, it's going to look like negative 1 over 3x. And then 15 divided by 3 is 5. And again, it's useful to be able to change from standard form to slope-intercept form so that I can quickly graph. Also, like slope-intercept form is a little bit easier to look at. Standard form's kind of weird. However, I say that standard form does have its uses. It's used best for story problems, which I know we don't love story problems, but it's really good for story problems because it's really versatile. So you're going to use standard form in a story problem when they give you actually 3 numbers, because they're always going to give you your A, B, and your C number to put in, which is super nice. So the 3 numbers that you're going to be looking for, like if we think about the A number, so over here, your A number, that will be like a slope number, a rate of change. So slope, rate of change, which seems weird because it's not really slope, but because it's being multiplied to x, it's a number that's going to change over and over and over again for one variable. So over and over number. B, your B number, is also going to be a slope number. So it's also going to be a slope or rate of change number, an over and over again number, but for a different thing. So that's why this is so good. Normally you can only have 1 slope, but for standard form, you can have 2 slopes. So it might be something like where you, every time you buy a pen, it costs $2, but every time you buy a pencil, it only costs $1. So that's 2 different things because I have pens and pencils, and one costs $2 and the other costs $1. So those are 2 different slope numbers. Or like, buying a Hershey bar costs $3 every time you do it versus buying, Skittles costs $2.50 every time you do it. Hershey bar and Skittles are my X and my Y, and then you have 2 different slopes because they cost 2 different prices. So that's super good. Your C number is going to be a total number. So in both of the examples I just said, like pens and pencils or Hershey bars and Skittles, those are all talking about the cost of things. So like the total cost of my candy, or the total cost of my writing utensils, or maybe it's like how much money total I have. Like maybe I have $20 and then how much can I spend? So it's always a total number, which makes sense too because it's like things added up equals this big one number, so total. So this is a really good example here of, I want colors, I need one more color. Got it. This is a really good example here of a story problem that would use standard form. Okay, so we're going to be looking for a slope number, another slope number, and then a total number. So as I read through, you're purchasing plants and have $30 to spend. Small plants cost $2 each, and large plants cost $6 each. So each is a really good over and over and over number. So I could say that the small plants being $2 a piece is my A number, because I'm going to do 2 over and over and over again for small plants. But I also have another over and over and over again number, and that's for large plants. When I'm buying large plants, they cost $6 each. So that's another over and over and over again number because of the each word, but it's for a different thing because large plants are large and small plants are small, and they cost different prices, so they can't be the same letter. which kind of like process of elimination tells me what 30 is, but like I have a total of $30 to spend. That's all I have. So that's why it's my total number. So a couple of things to talk about. You know, like I can put in my A number and my B number because I have all of these, but if I do that, so if we write it out, 2x, because 2 is going to be my A number, 2x, plus 6y, because 6 is going to be my B number, equals 30, the total number. That's all well and good, that's fine, but we kind of need to tell everybody what X and Y stand for. So in this case, X stands for small plants, and Y stands for large plants. And you could even, instead of using X and Y, use a letter that is a little bit more descript. So maybe I write it instead as like 2S for small plants plus 6L for large plants equals 30. I mean, they're really the same. You're just using more descriptive letters. So now again, it kind of feels like we're not done because we just wrote the equation. They might ask questions after that, like, you know, what if you don't buy any small plants? How many large plants could you get? Or what if you don't buy any large plants? How many small plants could you get? So they have to give you a little bit more information if you're going to answer a question. We just wrote the equation and that's it. Now, the last thing we got here, we talked about a little bit in the last time we talked about standard form, and that's our X-intercept and our Y-intercept. Those things are really easy to find when we're in standard form because the X-intercept is always going to be at a number comma 0. So that means no matter what, Y will always be 0. So in the equation, AX plus BY equals C, I can always replace Y with 0, which will make this whole term disappear. So in place of Y, I put 0. 0 times anything disappears, and so we're left with AX equals C. And then to solve for X, I just divide by A, and I know it feels weird to do it with all letters, but normally you're going to be doing it with numbers, and we're going to try something like that. The Y-intercept is very similar, except it's the flip. So X will always be 0, and I'm going to figure out what Y is going to be. So again, when I take my AX plus BY equals C here, 0 will go in for X, which will make that whole term disappear because 0 times anything is gone. So we'll just have BY equals C, and then to solve for Y to get all by itself, we divide by B. And again, I hope you're not freaking out too much that they're all letters. We're going to do some numbers in the next one. So Y equals C over B. There you go. See you in the next one.